let's stop and think about some of the technological hurdles that separate our current space exploration capabilities from our science fiction dreams of interstellar travel. There are a few that come to mind: artificial gravity, transporters, universal translators, but one constant among all of our visions for the future is the ability to travel very quickly through space, hopping between planets and solar systems in relatively small amounts of time, hours or days, as opposed to years and centuries. Here in the reality of the 21st century, it still takes a few days just to get a heavy payload to our own moon, around 8 months to our neighboring planet Mars, and you're looking at a multi-year journey to the outer planets like Jupiter and Saturn. That would make for a pretty boring science fiction series, but NASA has a plan to change all of that. And this one is rooted firmly in science fact. An experimental propulsion technology that goes back decades has finally returned to the forefront of aerospace innovation. To boldly go where no one has gone before, NASA is going nuclear. This is the space race. This new announcement involves two very important branches of the United States government, both NASA, the National Aeronautics and Space Administration, and DARPA, the Defense Advanced Research Projects Agency. The two operations are set to perform a scientific fusion dance that will result in the first ever human spacecraft to be powered by a nuclear thermal rocket engine. Now, that might sound scary, but it's actually a pretty simple concept, and it is incredibly practical for spaceflight. We'll get into how this propulsion system works in a minute, but first, let's talk about why this is so important. The NASA-DARPA partnership has been named the Demonstration Rocket for Agile Cislunar Operations, which has mercifully been shortened to DRACO. Pretty cool name. According to NASA Administrator Bill Nelson, the goal will be to, quote, develop and demonstrate advanced nuclear thermal propulsion technology as soon as 2027. With the help of this new technology, astronauts could journey to and from deep space faster than ever, a major capability to prepare for crewed missions to Mars, end quote. NASA Deputy Administrator Pam Melroy took things to an even more fantastic level of imagination, looking even deeper into the future by saying, DRACO will be a critical part of evaluating the technologies that will take us deeper into the solar system. Our intent is to lead and develop a blueprint for human exploration and sustained presence throughout the solar system. This is a very important goal, and we think that these advanced technologies will be a critical part of it. There's a bit to unpack here. DRACO is expected to come online in a relatively short time frame, less than 5 years from now. So that would imply that these agencies are pretty confident that they have this figured out. And like the name says, the first DRACO spacecraft will operate in cislunar space. That's the space in between the Earth and the Moon. And if this first demonstration is successful, then NASA wants to leverage nuclear thermal engines to send people all the way to Mars. Compared to the performance of a chemical rocket engine used in the vacuum of space, the nuclear thermal rocket should provide somewhere between 3 and 5 times greater efficiency. And that is going to translate to a spaceship that can travel faster, carry more payload, travel further distances, and maneuver through space much more quickly and easily than any vehicle we've used to date. In practice, that can mean reducing the transit time for a crewed mission to Mars from as long as 8 months to as little as 45 days. This is critical if we want to have a realistic discussion about sending human beings into deep space. The longer they spend in transit, the greater risk they will face. Likewise, the longer a crew has to live in the vehicle, the more supplies like food and water they will need to bring with them. And when we're talking about spaceflight, every single ounce of mass that you carry with you is important. Are you tired of the endless stream of misinformation and media bias that dominates today's news? Do you want to break free from the echo chambers and political polarization? Well, look no further. Ground News, the world's first news comparison platform, was founded by former NASA engineer Harleen Kaur. Ground News is a small team of independent media outsiders with a mission to well-inform the world by promoting critical thinking and diversity in news consumption. With Ground News, you can easily compare news coverage from left, center, and right sources, spot media bias with their visual breakdown of news sources, check your blind spots, and discover underreported news stories. Stay informed about international news with their interactive map, and personalize your feed with the My News Bias dashboard to track your reading habits. People need tools to navigate this increasingly complex media landscape, and Ground News is here to help. Take advantage of the opportunity to stay informed in a world of misinformation. Visit ground.news/spacerace to try Ground News for free and make a difference in the way you consume news. Subscribe now and support a small team of independent media outsiders working to make the news more transparent. Under the Draco Agreement, NASA will be in charge of developing and fabricating the nuclear rocket engine. They apparently already have a contractor selected for that job, but that company has yet to be announced. Although we do know that in July 2021, NASA awarded funding to 3 proposals for nuclear thermal engine development. Those grants went to BWX Technologies, who are partnered with Lockheed Martin, General Atomics Electromagnetic Systems, partnered with Aerojet Rocketdyne, and Ultra Safe Nuclear Technologies, who are partnered with Blue Origin and General Electric. Of course, as you might have noticed, the one with the fake-sounding name has Jeff Bezos involved. The dude just... Anyways, one of those 3 partnerships between Legacy Aerospace Technology and nuclear research will create the propulsion system for our first ever nuclear spacecraft. DARPA will be the agency responsible for leading the development of that space vehicle, codenamed X-NTRV. DARPA also awarded 3 contracts in 2021 for a Phase 1 exploratory development. No surprise here, those also landed in the hands of Aerojet Rocketdyne, Blue Origin, and Lockheed Martin. The work that is about to take place on Draco is the realization of a plan that first came together back in the 1960s. A brainchild of the so-called father of space travel, Wernher von Braun, a former Nazi scientist turned NASA engineer. To be fair, we didn't really find out about the Nazi thing until after he was dead, so it sounds a little worse than it was. But anyway, as early as the 1960s, von Braun had created blueprints for nuclear rockets that would take humans to Mars by the 1980s. The original idea for Apollo was to act as a springboard for Mars exploration that would begin as early as 1979. Unfortunately, the funding just never came together, but the concept was rock solid. Okay, let's start off with our current generation rocket technology. Liquid rocket engines are fairly simple in their design. You have 2 tanks, one containing rocket fuel and one containing liquid oxygen. Those 2 elements are pumped into a combustion chamber and then exploded. The explosion produces exhaust gas that is pushed through a nozzle to accelerate its flow and produce thrust. The fuel that we use varies by application. Most current launch boosters use a highly refined kerosene called RP1, and most upper stage engines use liquid hydrogen fuel. More modern rocket designs like the SpaceX Raptor and Blue Origin BE-4 use liquid methane fuel for both the first and second stage engines. We liquefy gases like oxygen, hydrogen, and methane by supercooling them to extremely low cryogenic temperatures. We do this to increase the density of the elements and make for a more powerful reaction in the combustion chamber. A nuclear thermal rocket engine operates using the heat generated by a nuclear reactor. In this case, we are talking about nuclear fission, which is also referred to as splitting the atom. And those atoms come from the element uranium. Uranium atoms are bombarded with free electrons that split the nucleus of the uranium into 2 or more smaller nuclei. That splitting process releases a very large amount of energy, and it also creates more free electrons that fly off and split more atoms. So you have an ongoing chain reaction that continuously generates new energy. The nuclear energy of fission would replace the chemical energy of exploding propellants in the rocket engine design. It's expected that the heat generated by the Draco reactor will reach around 5,000 degrees Fahrenheit, or 2760 Celsius. In order to convert that nuclear heat energy into thrust, we will still need a liquid fuel source. In this case, we would be talking about liquid hydrogen. Hydrogen is the lightest element in the known universe, making it the ideal thing to carry on a spaceship. And when that liquefied hydrogen is pumped through the reactor core by a high-speed turbopump, the extreme heat causes the liquid to rapidly boil and expand into a gas, which is then pushed through the nozzle and creates thrust. So imagine a jet of steam pushing the spaceship forward. There is no combustion involved in this process, and that means there is no need for the oxidizer. Not only have we increased the potential for maximum thrust by using a much more efficient thermal reaction, but we've also greatly decreased the mass carried by the vehicle by removing liquid oxygen from the equation. If that sounds like an ideal way to move through outer space, that's because it is. This is the reason that NASA believes an operational nuclear thermal propulsion system will basically unlock the solar system to human exploration. Now, it's not unreasonable to be a bit worried about the overall safety of a project like this. Obviously, we've seen some pretty terrible results in the 20th century from the misuse of nuclear fission energy, either as an intentional weapon or an accidental disaster. So, it is important to remember that when we are talking about these nuclear engines, they will only operate in the vacuum of space. A conventional chemical rocket booster will send the vehicle through the atmosphere and into orbit. Only once it's up there and away from the Earth will the nuclear reactor be activated. And even if there were to be some kind of a failure on the ground, say the whole rocket just explodes on launch, which hardly ever happens, then it would not explode like a nuclear bomb with a giant mushroom cloud and stuff. Nuclear bombs are more complicated than just blowing up some uranium. That's what they call a dirty bomb, which is also very unlikely to happen. If we remember that the reactor needs to be shielded well enough to prevent 5,000 degrees of radiative heat from cooking the people on board the ship, then it stands to reason that the same containment would keep the reactor in one piece even if the whole thing were to explode. Anyway, all that to say, I wouldn't be worried about it. And it's the upsides of this technology that really inspire the most thought. A crewed flight to Mars in less than 2 months. We could send people to observe Saturn and Jupiter and witness these unfathomable cosmic entities through human eyes. Giant nuclear-powered ships assembled at spaceports on the Moon and Mars that transit the entire solar system, exactly like what you'd see in the Expanse science fiction series. It's not that far out of reach. So, do you think this is something that NASA and DARPA can pull off in just 5 years? Let us know your theories on nuclear space travel in the comments below. Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it. That really helps us out for real. And subscribe to the Space Race for more videos just like this. We do one long form essay and one news update every week. And if you'd like more, we've got 2 more on the screen for you right now.